Welcome to this channel. Today we are going to be looking at using the discriminant to determine the number and the nature of roots of a quadratic function. So first off, the discriminant is calculated by b squared negative 4ac in accordance to the general quadratic form, which is a squared plus bx plus c equal to 0, where a is not equal to 0. It was actually gotten from the quadratic formula, this compartment right here, b squared negative 4ac. So all we need to do is to substitute the values a, b, c in accordance to whatever quadratic equation we are given, and then determine the discriminant, and then use it to determine the number and use it to determine the nature of the root. So let's go right in. So there are things to note about the discriminant. 4 important things to note. So the first thing is that if the value of d, I've told you that the value of d is given by b squared negative 4ac. The value of d is greater than 0, that is b squared minus 4ac greater than 0, then that implies that the function has real distinct roots. Because if this is greater than 0 according to this equation, then to have two distinct roots from the plus and minus. Then if d is equal to, which is equal to b squared minus 4ac, is less than 0, that means it has imaginary roots. Because if this compartment is negative, the square root of a negative number is imaginary. And if the value of d is equal to 0, then that means the function possesses real equal roots. Hence, you can say that it possesses real and equal roots. Then the value of d is greater than or equal to 0. Please, the first three are the most important. The value of d is greater than or equal to 0. Then that gives us like a set of values for which it is equal and then also distinct. It's just like set of values. The first three are the key ones: greater than 0, less than 0, equal to 0. And there's something we need to know about this stuff when comparing it to a line and a curve. Sometimes we see that lines and curves intersect, sometimes they don't intersect, sometimes they intersect at only one point, sometimes they intersect at 2 points, especially for quadratic curves. So there are things that we could use these discriminant values to determine whether a line and a curve are going to meet or not, or whether they're going to intersect, or whether they're going to intersect at 2 different points. So if the first condition is b squared negative 4ac greater than 0, the function has real distinct roots. So if we equate the equations of the line and the curve in the form as squared plus bs plus c equals to 0, the first condition is true. The line will intersect with the curve at 2 real distinct points. Right? Then if the second condition is true, that's b squared negative 4ac less than 0, after you have equated the line and the curve, then that means that the line and the curve will never meet for those set of values. Then if the third condition is true, that means equal roots. The third condition says b squared negative 4ac is equal to 0. That means it will intersect at only 1 point, or we can say it will be a tangent. Then if the fourth condition is true, it may intersect at only 1 point or 2 distinct points. That's why I said it's a combination of 2 conditions. So let's go right in to what we have to do. The first question is, the equation of a curve is given by y equal to x squared plus 5x plus 6. Given that y is equal to 0, determine the discriminant of the equation x squared plus 5x plus 6 equal to 0. And using your value in I, determine the nature of the roots at the equation x squared plus 5x plus 6 equals to 0. So all we need to do is to substitute in the formula b squared negative 4ac. And in this case, the value of a is 1, the value of b is 5, and the value of c is 6. So if you do that, we have 5 raised to the power 2. That's 5 squared negative 4 times 1, which is 8, times c, which is 6. So 5 squared is 25. 4 times 1, 4 times 6, 24. 25 minus 24 is 1. And so since the value of d is greater than 0, then we can deduce and say that the equation possesses real and distinct roots. Let's take the next question. You can pause the video and attempt this question on your own. F of x is equal to x squared plus 6x plus 9. F of x is equal to 0. Determine the nature of the roots of the equation formulated. So if f of x should be equal to s squared plus s plus 9, and f of x should still be equal to 0, then we could write that s squared plus 6s plus 9 is equal to 0. And then if we compare with the general quadratic equation, the value of a is 1 because the coefficient of s squared is 1, the value of b is 6, and the value of c is 9. So substituting in b squared minus 4ac, we'll have c squared minus 4 times 1, a is 1, c is 9. 36 minus 36 is 0. So since the value of d is 0, according to the condition stated in this video, the equation possesses real and equal roots. That. Okay, question number 3, we take another question. If g of x is equal to 2x squared negative 9x plus 15, equate g of x to 0 and hence determine the nature of the roots of the equation that has been formulated. So we compare with the general form as usual. The value of a in this case is 2 because the coefficient of x squared is 2. The value of b is negative 9 because the coefficient of x is negative 9. And the value of c, which is the constant term, is positive 15. So we substitute in b squared means negative 4ac. So negative 9 all squared minus 4 times a, which is 2, times c, which is 15. Negative 9 squared is the same thing as 9 squared. That's going to give us 81. 4 times 2, 8 times 15, that's 120. And 81 negative 120 is negative 39. And since the value of d is less than 0, then we could deduce that the equation possesses imaginary distinct roots. Okay, so next we're looking at there are some things I told you to note in some parts of the video where we talked about a line and a curve intersection, stuff like that. So we're going to take this question. That question is based on that. The question says the equation of a curve is y equals to 2x negative 3 x squared, sorry for the typo there, 2x negative 3 x squared negative kx negative k negative 2, where k is a constant. The line y equal to 3x negative 4 is a tangent to the curve. Find the value of k. When we're talking of tangent, that means the line is going to touch the curve at only one point. And that satisfies the condition b squared negative 4ac equal to 0. That's a tangency, 1 point. Equations that have one root are only going to touch the x-axis or may not even touch the x-axis, but only 1 point. Only 1 point. So comparing, value of a in this case is 2k negative 3 because the coefficient of x squared is 2k negative 3, the value of b is negative k, and the value of c is negative k negative bracket k negative 2. So continuing that, moving on, we then equate the curve and the line, as I said earlier in this video. So we'll now have 2k negative 3 x squared negative kx negative bracket k negative 2 equal to 3x negative 4. So we bring these two guys here to the left hand side of the equation so that it will conform to ax squared plus bx plus c equal to 0. So we then have 2k squared 2k negative 3 x squared negative kx negative 3x as the 3x has transferred to the left hand side, and negative 4 turns to positive 4 on the left hand side of the equation. Then we group them together because both possess x and the constant terms. So we then have negative kx negative 3x, so we could factor out negative x, and negative kx divided by negative x is positive k, and negative 3x divided by negative x is positive 3. Then negative times k is negative k, negative times negative 2 is positive 2, then plus 6. So at the end of the day, we have this 2k negative 3 x squared negative x bracket k plus 3 negative k negative 6, because on expansion of this, we're still going to have negative k plus 6, which is what we had initially here. So as I said, comparing, we're going to have a as 2k negative 3, b as negative k plus bracket k plus 3, sorry, and c as negative bracket k negative 6. So substituting in b squared negative 4ac, b is negative k plus 3, so we're going to square it. Negative is going to cancel the negative. So minus 4 times a is 2k negative 3, times minus k negative 6 the negative right here is going to cancel the negative right here. So, and the negative k of k plus 3 all squared is going, the negative is going to cancel because negative times negative is positive. So we have k plus 3 squared plus 4 bracket 2k negative 3 times k negative 6 equal to 0. So we expand k plus 3 squared, and if you should expand k plus 3 squared, that's same as x plus 3 times x plus 3. So k times k plus 3 plus 3 times k plus 3, the expansion, k times k squared. K times 3, 3k. I made mistakes here. 3k, sorry. So 3k, 3 times k, 3k, sorry. 3 times 3, 9. So we have k squared plus 6k plus 9. And then we resolve the other part of the equation, which is 4 bracket 2k negative 3k negative 6. So we take out the 4 and then resolve and then multiply this. Now if you take k times 2k minus 3 minus 6 times 2k negative 3. So k times 2k is 2k squared. K times negative 3 is negative 3k. Negative 6 times 2 is negative 12k. Negative 6 times negative 3 is positive 18. So we can have 4 bracket 2k squared negative 3k negative 12k plus 18. And then resolving that, we're going to have 4 brackets, that. And then we now open the bracket, and that's going to be 8k squared. 4 times negative 15, negative 60k, and 4 times 18, that's 72. So we have 8k squared plus negative 60k plus 72. Then remember we added k plus 3 all squared and 4 bracket 2x, 2k negative 3, bracket k negative 6. So we're going to add them. K squared plus 8k squared is going to give us 9k squared. 6k negative 60k is 54k. And negative 54k, and 9 plus 72 is positive 81. So we then have 9k squared negative 54k plus 81 equal to 0. So if you look at this equation, you can see that 9 is a factor of every single element. So we can divide through by 9. 9 into 9 is 1. Negative 54 into 9 is negative 6, and 81 into 9 is still 9. So we have k squared negative 6k plus 9 equals 0. Then we can factor this and get the solutions. So the two numbers we can add, that's going to give us negative 6, and we're going to multiply. That's going to give us positive 9, is negative 3 and negative 3. Negative 3 is negative 6, and negative 3 times negative 3 is positive 9. So looking at k squared negative 3k, we can see that k is common. So we bring out k, we factor out k. So k squared divided k is k, and negative 3k divided k is negative 3. If you look at negative 3k plus 9, what's common is negative 3. So we factor out negative 3. Negative 3k divided by negative 3 is k, and 9 divided by negative 3 is negative 3. So we take this, and we take this. So we then have k negative 3 times k negative 3 as equal to 0. So then we could say that k negative 3 equal to 0 twice. Then negative 3 moves to the right hand side of the equation, and then we can say that k is equal to 3 twice. So the value of k for which the curve and the line, that's the lines are tangent to the curve, is when k is equal to 3. So let's solve the next question. A quadratic equation is given by 16x squared negative 24x plus 10 equal to k. Where k is a constant, it has exactly one root. Find the value of k. So for a quadratic equation to have only one root, just like the equation we just solved previously, it had just one solution, which was 3. So that means it's going to have equal roots. Equal roots. That means b squared negative 4ac is going to be equal to 0. So all we need to do is to take the k on the right hand side of the equation to the left, and that becomes 16x squared plus 24x plus 10 negative k equal to 0, because it has to confirm with ax squared plus bx plus c equal to 0. So in this case, we could say that A is equal to 16, B is equal to negative 24, and C is equal to 10, negative 8. And substituting in B squared negative 4AC, remember B is negative 24. Negative 24 squared minus 4 times 16 times C, which is 10 minus K, right? So negative 24 all squared, remember that negative times negative is positive. So 24 squared, negative 24 squared is positive 576. 4 times 16 is 64. Bracket 10 negative K. And if we should do the expansion, we're going to have 64 times 10, that's 640, that's negative 640. Negative 64 times negative K is positive 64. Then next is to do 576, negative 640 on your calculator, and that's going to give you negative 64. And then you have negative 64 plus 64K equal to 0. Then we could move the negative 64 to the right hand side of the equation, and then it becomes positive 64. Then we have 64K equals 64. Then we divide through by 64. 64 divided 64 is 1. Then we could say that the value of K is 1. We're going to take the next question. And it says, find a set of values for which the equation 2x squared plus 3kx plus k equal to 0 has distinct roots. And according to the condition stated in the other part of this video, we said that if you should have distinct roots, that means the b squared negative 4ac is 0. And if you look at the equation on the screen, the value of comparing the general form, the value of a is 2 because coefficient of x squared is 2. The value of b is 3k, coefficient of x is 3k, and value of c is k. So all we need to do is to substitute and equate to 0. So then we're going to have 3k all squared minus 4 times 2 times k greater than 0. So 3k all squared, 3 squared is 9, and k squared is k times k is k squared. So we have 9k squared negative 8k greater than 0. Then if we look at 9k squared negative 8k, we can notice that k is common to both elements. So we could take out k. Alright, so we could take out k, and then we're going to have k out. Then 9k squared divided by k, this k is going to cancel k, and we're going to have 9k. And negative 8k divided 8k is going to leave us with negative 8. So we could say k bracket 9k negative 8 is greater than 0. And for this to be true, it's either you have negative negative or positive positive, because negative times negative is going to give us a positive, which is greater than 0, or positive times positive is there. So taking the case of k greater than 0 and 9k greater than 0, k greater than 0, right? Then 9k negative 8 greater than 0. That's going to give us 9k, because negative 8 will cross over, and we now have 9k greater than 8. And if we have 9k greater than 8, we divide through by 9, then we have k greater than 8 over 9. And then when we take the next case of negative negative is going to give us k less than 0 and k less than 8 over 9. But if we study this closely, if you study inequality, look at the other part of the function, k bracket 9k negative 8 greater than 0. So if we look at it closely, the only stuff that's going to satisfy this inequality is actually when k is greater than 8 over 9 and when k is less than 0. Because if k is less than 0, that means we're going to have negative negative, which is going to give us positive. And if it's greater than 8 over 9, we are still going to have a positive number. But if we use k greater than 0 at some point, we're going to have a negative number, which is going to contradict the purpose of that inequality. And so we just take this combinations, k less than 0, k greater than 8 over 9. That's going to satisfy the inequality. So that's the set of values of k for which it has distinct real roots. The next question we have is find the set of values of m for which the line y equal to mx plus 1 and the curve with the equation y equal to 3x squared plus 2x plus 4 intersects at two distinct points. And for this to happen, as I said, that means that b squared negative 4ac is greater than 0. Real distinct roots. So the first step is to equate the two, equate the equation of the curve and the equation of the line. So we equate it. And then we have mx to the left becomes negative mx, and 1 to the left and becomes negative 1. So we have 3x squared plus 2x negative mx plus 4 negative 1 equal to 0. And then at the end of the day, we have 3x squared plus, we can take out x because x is common to 2x and mx, and then we have x bracket 2 negative m, and 4 minus 1 is positive 3. Then we use our condition, b squared negative 4ac equal to 0, and comparing with the general form, a is equal to 3, b is equal to 2 negative m, as that's the coefficient of x, and c is equal to 3. So substituting that, then we're gonna have 2 minus m all squared, negative 4 times a, which is 3, times c, which is 3. So 4 times 3, 12, times 3, 36. So we have 2 negative m all squared negative 36 as b squared negative 4ac, then greater than 0. Then when negative 36 crosses to the right hand side of the equation, we are then gonna have positive 36, and we're gonna have stuff like this, right? So to clear the square, we're gonna find the square root of both sides. And find the square root of both sides, we're gonna end up with 2 negative m greater than plus or negative 6, because the square root of 36 is plus or negative 6, right? So we could say that 2 negative m is greater than 6, and 2 negative m is less than negative 6. Why do we say 2 negative m is less than negative 6? Because if we should state the numbers that are less than negative 6, numbers less than negative 6 are negative 7, negative 8, negative 9. And if we should square negative 7, right, that is going to give us 49, which is actually greater than 36. But if we should have said 2 negative m greater than negative 6, numbers greater than negative 6 are negative 5, negative 4, and negative 5 squared is 25. Negative 4 squared is 16, which is less than 36. So, but 2 negative m greater than 6 is accepted because numbers greater than 6 are 7, 8, 9, and all of them are, when they are squared, are above 36. So those are the two conditions. So then we solve the first part. This 2 crosses to the right hand side of the equation and becomes negative 2, sorry. So we have negative m greater than 6, negative 2. So we have negative m greater than 4. And if we should divide through an inequality with the negative sign, the sign of the inequality is going to change. So we're now going to have m less than negative 4. That's the rule. Then the second case, 2 negative m less than negative 6. So the 2 crosses to the left hand side of the equation and becomes negative 2. So we have negative m, negative 6, negative 2 is going to give us negative 8. So we have negative m less than negative 8. So since we're dividing through by negatives to make it positive, the sign is going to change and we're going to have m greater than 8. So the solution is actually m less than negative 4 or m is greater than 8. So that's the solutions, the set of values of m for which the curve and the line intersect at two distinct points. Thank you so much for watching this video to this point, and I encourage you to subscribe, like, and share. Do well to subscribe so that you can receive more content that are similar to this, and that will be all for today. Thank you.